Hello everyone, welcome back to my YouTube channel. Please, if you have not subscribed, please do well to subscribe to my YouTube channel. Thank you. So today we'll be talking on work, calculation under work, and also calculation under energy. So what is work? Work is a product of force and distance. So the formula for work, if you want to solve any calculation involving work or work done, is W is equals to F times D, where W is called work done and the unit of work done is in joules, or you can write capital letter J, and the F is force and the unit of force is in Newton, or you can write capital letter N, and D is distance and the unit of distance is in meters, which is small letter m. Now we also have what we call work done against gravity. We know the law of gravity, that everything that goes up will surely come down. So it's taking the place of force there, because force and gravity has something in common. So therefore, the force in the formula for work will be changed to what force is called, because force has its own formula, which is mass times acceleration, or you can call it mass times gravity. So therefore, work done against gravity is equals to W is equals to mgh. Also, acceleration due to gravity is a constant, whereby the small letter g is a constant. It can be 10, or some persons use 9.8, but if you round it off to the whole number, that is 10. So sometimes you might see it as 10, or sometimes you might see it as 9.8. So where W is called the work done, which we know the unit J, which is joules. Also mass, M is called the mass, which is in kilogram, kg, and G is the acceleration due to gravity, which is in meter per second square. And also h is called the height. Height is also called distance, because you are measuring from up to down or from side to the other side is also distance. So the unit is in meter. Now let's talk about the example. We have this example. They said a boy of mass 50 kg runs up a set of steps of a total height of 3.0 meter. Find the work done against gravity. Full stop. Take G to be equal to 10 meter per second square. Now solution. Before you start solving any calculation question, make sure you write out the parameters. Parameters are also called data given. That is what and what you notice in the question that they have given you, or what and what you are to look for. So you have to write it down. So, and you can write it according to how you are reading it, so that you will know. So me, I'm doing my own according to how I'm reading it. So after reading it at first, if I want to start solving, I'll read again. So reading again, a boy of mass 50 kg, it means that the m is equals to 50 kg. And even if they did not write mass there, because I know that the unit of mass is kg, I will know that 50 kg is standing for mass. And also h, which is the height, is 3.0 meter. That is what is there. And they said find the work done against gravity. We are looking for W, which is question mark. We don't know what is it. And full stop. Take G to be equals to 10 meter per second square. That is, our G should be equal to 10 meter per second square. But Adibi, they did not give us this one in brackets. We are supposed to know that acceleration due to gravity is a constant. It's not something that we can just forget. It's a constant. It's something that must be there. So should, in case you are solving any other question and you know that in your formula acceleration due to gravity is there, just know that is a constant, which is you can use 10 meter per second square, or you can also still use 9.8 meter per second square. Now we write our formula, which we know. Through our parameters, you can know the formula you are to use. So we cannot use this first one that has F times D, because they did not give us F here. So we only saw mass H, W and G. So the formula we are to use is this, which is W is equals to mgh. W is equals to mgh, whereby we are looking for W, which is question mark, and glory be to God is already made the subject of the formula. But Adibi is not made the subject of the formula. Any other thing that we are to look for, if they've not written it like this, equals to, before solving, before imputing your coefficient, make sure that you make that particular thing the subject of the formula. So W is equals to our M. What is our M? 50. So write 50. When something is joined together like this, it means multiplication. Times our G from our parameters is how many? Is 10. So write it 10. Times our H, which is called what? Height, is 3.0 meter. 3.0 meter. So write it 3.0. So if you calculate everything, we are going to get 1500 joules. So we are going to put the units. Don't forget, whenever you are looking for anything, since we are looking for W, after getting our answer 1500, we cannot just leave it as 1500. We must write the unit, which is also what? Joule, so that the person marking your script will know what you are talking about. So that is that for work. Now let's go to the next one called energy. Energy. Now energy is the capability to do work. We have so many types of energy. We have solar energy, we have light energy, we have chemical energy, we have heat energy, we have mechanical energy, and so on and so forth. Now inside those types of energy, the one that I have just mentioned called mechanical energy is divided into two, which is called kinetic energy and potential energy. So if they are telling you to give them types of energy, don't call kinetic energy or potential energy. They are not types of energy, but rather they are types of mechanical energy. So the first one, which is kinetic energy, is a type of energy that is due to motion. Is the type of energy that is possessed due to motion, that is something that is in movement. Is type of energy that is carried out when moving or in motion. So the formula to solve, if you want to solve a calculation involving kinetic energy, is Ke equals to 1/2 mv square, where Ke is equals to your kinetic energy in joules, which is capital letter J, and M is equals to mass in kilogram, which is kg, and the V is also what we call velocity in what? In meter per second, which is m/s. That is the symbol of the unit. Now they gave us an example. They said an object of mass 0.5 kg has a kinetic energy of 25 joule. Full stop. Calculate the speed of the object. Now you are going to be taking speed. How come? Why did they call speed whereas kinetic energy has velocity? Now velocity and speed has something in common. They are almost the same. Velocity is the rate of change of velocity is the rate of displacement with time, while speed is the rate of distance move with time. So velocity and speed has the same units, which is meter per second, but the only difference between velocity and speed is direction. Now for that of velocity is something that has direction, be it north, east, west or south, but that of speed, it does not have direction. So most times they can be talking about speed, most times they can be talking about velocity. They are almost the same. So as far as you already know that, oh, kinetic energy wants us to be using what? V. So you cannot help them to change the V to S. So you just leave it like that, since the two of them are still measured in the same unit. So calculate the speed of the object. Now, before writing or before solving, even if you know the formula that you can use, write out your parameters. That is either the data given or what they gave you or what you are looking for. So we saw mass there, which is m is equals to 0.5. Also, we saw that they have kinetic energy of 25. So Ke is equals to 25 joules. Calculate the speed of the object. So my speed is representing velocity, which is v, equals to we don't know, which is question mark. So our formula to solve is Ke is equals to 1/2 mv square. Now, I cannot start solving like this, or I can start but so that my work will not get scattered, I will have to make my velocity the subject of the formula, since that is what I'm looking for. But here it's Ke that is the subject, so I will have to change Ke to be v. So I will do change of subject of the formula with this formula. So I will start. My Ke is equals to, when you have fraction and whole number, the numerator of that fraction will multiply the whole number, but what is down will use it to divide it. So what is down and the whole number, they don't have anything in common. So it's only the numerator that has something in common with the whole number. So that's why we have 1 times m times v square over 2, which is all of them will now have the over 2. Then start solving again. Ke is equals to 1 times m times v square will give us mv square, because it's not possible for us to write 1 mv square. As the mv square is standing, it means they are 1. So no need for you to show the 1 again, over 2. Now, the next thing that we can do, because all our main focus is on how to make v the subject of the formula, is to cross multiply. So our Ke equals to mv square over 2. Here we can put over 1 so that it can be in fraction form, because anything divided by 1 too, we'll still get that thing. So if we do Ke divided by 1, we'll still get Ke. So cross multiply, because there is equals to in the middle, we'll cross multiply. Cross multiply means that this one up will meet this one down, and this second one up will meet this second one down. So we have Ke times 2, this is it here, and we have mv square times 1, this is it here. So Ke times 2, which is our kinetic energy times 2, we'll get 2Ke, equals to mv square times 1, we'll still get mv square. So the next thing that we have to do here, since is v that is our main focus, is to divide both sides by what is blocking our v. And the thing that is blocking our v here now is m, because we are trying to remove every obstacle so that we can get our v as the subject of the formula. So divide both sides by m, that is, we are to divide the two sides by m. Then if we divide two sides by m, we have 2Ke equals to mv square. We want to divide the two sides by m, the left hand side and the right hand side. We want to divide them by m. So the m in the down, we cancel the one up. So do you see that v is now standing now? So we have v square on its own equals to 2Ke over m. But something is still blocking our v, which is the square. So for us to remove this square, we are to take the square root of both sides. Is either you take square root of both sides or you transfer square. And whenever you are transferring square, it will turn to square root in the other side. So let's take square root of both sides in this one. Now we have v square is equal to 2Ke over m. So if you draw your square root sign, the square will cancel square root. So only v is standing. Therefore, your v will be equals to the square root of 2Ke over m. Now we can start imputing our coefficients, that our data given, the thing that they gave us, we can start imputing it now. Because why? We already make our v to be what? To be the subject of the formula. Our V is now already what? Already the subject of the formula. So we have V is equal to the square root of 2ke over m. Now start solving. Very simple. Follow step. You don't rush whenever you are solving. So V is equals to the square root of 2 times what is our ke? The ke they gave us was 25 over what is our m? Our m is 0.5. Therefore you continue. V is equal to the square root of 2 times 25 will get 50 over what? 0.5. You still continue again. V is equal to the square root of, now you will now do 50 divided by 0.5. So 50 divided by 0.5, we are going to get 25. Therefore, our V is equals to, what is the square root of 25? You write it 5. Then the unit of our V, which is our velocity, is meter per second. So that is how to solve kinetic energy. Now let's go to the last one called potential energy, which is the second type of mechanical energy. Now this potential energy is the type of energy that is possessed due to its position. Is the energy that is in position, that function due to its position. Now P is equals to mgh, where P is called the potential energy in what? In joules. Just know that energy and work, they have the same unit. So if you are looking for work, the unit to be in joules. Also, if you are looking for energy, mere kinetic energy or potential energy, their unit is in joules. Now m is mass in kilogram and g is called acceleration due to gravity in meter per second square. Don't forget, it is a constant, which is 10 meter per second square, or you can write 9.8. Now h is equals to height in where? In distance, that is in meter rather, because height, length, breadth and anything, they are all called distance, so their unit is in meter. Now we also have an example. They said an object whose mass is 43 kg is hanging on a thin wire. Full stop. The object has a potential energy of 3160.5 kg, 0.5 J, which is joules. Full stop. How high is the object above the ground? Now solution, we write our data given. They gave us m, which is our mass, 43 kg, and they gave us potential energy P, and our P is 3160.5 joules. Now we are looking for how high, that is the height, which is h, we don't know, question mark, and our G, because this formula has G, so we have to put it. And I've already tell you that if they do not put it here, you should always know that it's a what? It's a constant. So this is 10 meter per second square. So we can start solving. PE is equal to mgh. Now the same thing that happened when we were solving kinetic energy, that is also what is happening here. We are looking for H. H is not made the subject of the formula, but why? It's only PE. So we have to make H the subject of the formula first before we start solving. So here we just have P is equal to mgh. You are just to look at it. What is blocking our H is only M and G. So what you can do is to divide both sides by M and G. So if I divide both sides by M and G down here and M and G up here will cancel. Therefore, only H will be left alone. So that's why the H is here equals to PE over the mg. Now I can start solving because my H already has equals to now. It's not standing. So H is equals to, what is my PE? 3160.5 joules. I'll write over my M is 43 times 10. So I will solve. H is equals to, solve, write the one up, solve for the one down, which is 43 times 10. I'll get 430. Then I'll divide these two. So my H will be equal to 7.35. Or if I do the approximation sign to whole number, anytime you are approximating, make sure you are putting the approximation sign. Then the answer will be in 7 meter. which meter is the unit of height. So I hope this helps a lot. Thank you very much. Please do well to subscribe to my YouTube channel. Thank you.